and welcome to the April edition of VideoTec. We're going to be discussing the Eagle Talon all-wheel drive system. This unique system directs power flow to the front and rear axles, minimizing wheel slippage, enhancing vehicle stability, and improving traction, especially on slick surfaces. If when driving over loose or slick surfaces, either the front or rear axle begins to slip and rotate quickly, the center differential's viscous coupling automatically distributes torque to the other axle, allowing the slipping wheel to regain traction. An optional rear axle viscous coupling similarly distributes torque between rear wheels to further improve Talon's traction and cornering ability. The Talon's all-wheel drive system uses a center differential mounted on the output shaft of the conventional W5M33 front-wheel drive manual transaxle to distribute drive power to the front and rear wheels. Enclosed in the manual transaxle along with the center differential is a viscous coupling that controls differential action between the front and rear wheels. Differential action by the viscous coupling takes place between the outer and inner hub of the center differential case. The outer hub delivers power to the front output shaft, driving the front differential. The front differential is an open type, located inside the transaxle. The inner hub is locked to the center shaft, or rear wheel drive shaft, delivering power to the transfer assembly and propeller shaft assembly, driving the rear axle differential. There are two rear axle differentials available in the all-wheel drive system: the standard open differential and the optional viscous coupling type limited slip differential. The limited slip differential can be identified by a tag on the back of the housing. Well, that's a general description of the all-wheel drive system, but today we're going to go a little deeper into this unique system. We'll explain how a viscous coupling operates and how it affects the operation of the all-wheel drive system. We'll provide you with a method for testing the viscous couplings on the all-wheel drive system. We'll take a look at the viscous coupling at the center differential and go over the procedure for removing and replacing it. And then we'll remove the viscous coupling from the limited slip differential in the rear axle. We'll provide you with the servicing procedure for the Lobro joint on the prop shaft. And we'll discuss towing procedures. Finally, we'll discuss lubrication of the transaxle, transfer assembly, and rear axle of the all-wheel drive equipped Eagle Talon. So, let's get started by discussing how a viscous coupling operates. A viscous coupling consists of two sets of plates which are splined to a two-part shaft assembly. At the viscous coupling on the center differential, the inner plates are splined to the inner hub of the differential, which rotates with the center shaft and drives the rear axle. The outer plates are splined to the outer hub of the differential, which drives the front axle. Within the housing of the viscous coupling, the outer and inner plates are arranged alternately. The outer plates have spacer rings set between them on the outer edge in order to space them. The spacer rings are fixed to the housing. The inner plates have no spacer rings, and they can slide along the spline shaft between the outer plates. The plates are separated by a special silicone oil. The holes in the plates allow the silicone oil to flow through and to move with both inner and outer plates. When the front and rear axles are moving at the same speed, the plates are moving at the same speed, and the viscous coupling does not differentiate torque. But when one set of plates begin to move at a higher speed, the silicone fluid exerts force on the slower moving plates to reduce the speed difference between the plates. Under extreme conditions, the temperature of the silicone oil rises. When this occurs, the oil escapes from between the plates and the plates lock together. This is called differential lockup. It eliminates any differential action and maximizes traction under slippery conditions. When the speed difference no longer exists, the temperature of the silicone oil drops and normal function is restored. This locking and unlocking of the viscous coupling has been termed humping. Well, that gives you an idea of how the viscous coupling at the center differential operates. and how it affects the operation of the all-wheel drive system. The optional limited slip differential in the rear axle uses a viscous coupling that has the same operating characteristics as the viscous coupling at the center differential, but it supplies torque between the left and right rear wheels. If you suspect that either the viscous coupling at the center differential or the viscous coupling in the rear axle are not working properly, you can verify operation by using the following procedures. To test the viscous coupling at the center differential, raise all four wheels. Have a helper start the engine, release the parking brake, and shift the transaxle into first gear. Now, with the engine at idle, all four wheels should turn. If only the front wheels turn, the viscous coupling's not working properly. Now, raise the RPM to about 1500 and slowly apply the parking brake. With the parking brakes applied, there should be a drop in RPM as a load is put on the engine by the viscous coupling, which is trying to equalize torque between the front and rear axles. Again, if there is no drop in RPM, the center differential viscous coupling is not working properly and should be replaced. To test the viscous coupling in the rear differential, move the transaxle shift lever to neutral and completely release the parking brake. Then raise and support the vehicle on the hoist. Place mating marks at the rear differential and propeller shaft coupling and remove the 4 bolts. Now, slowly rotate one of the rear wheels. If the rear wheel on the other side turns in the same direction, the viscous coupling is okay. If the wheel turns in the opposite direction, replace the viscous unit. And remember, service the viscous couplings only by replacement. All right, now let's look at the procedure for replacing the viscous couplings. We'll start with the one in the transaxle. In order to remove the viscous coupling at the center differential, you must remove the transaxle from the vehicle. This procedure is provided in the Laser Talon service manual, but we'll begin the procedure with the transaxle on the bench. First, remove the 11 bolts from the rear cover of the transaxle. Notice that the 2 bolts at the bottom of the cover are longer. Use a rubber mallet to break the seal and remove the cover from the transaxle. Place the cover where the oil guide won't be damaged. Be aware that there's a wave spring on the synchronizer assembly that could slip off during disassembly. Remove the snap ring from the center shaft and then remove the viscous coupling. You may need to pry off the viscous coupling with a flat blade screwdriver. Be sure not to lose the steel ball from the inner hub and center shaft. The first step in replacing the viscous coupling is to install the steel ball into the groove in the center shaft. The ball can be held in place with petroleum jelly. It'll be necessary to push the center shaft up from the bottom of the transaxle until the ball drops into the slot in the center shaft. Now, install the viscous coupling, making sure the ball stays in place. Next, support the center shaft from the bottom and measure the snap ring groove with a feeler gauge. Select a snap ring so that the end play in the viscous coupling is within specification. End play must be 4 to 10 thousandths of an inch. For example, if the snap ring groove measures 66 thousandths, we need a snap ring that's between 56 thousandths and 62 thousandths, so that end play is between 4 and 10 thousandths. A list of snap ring sizes is provided in section 21 of the Laser Talon service manual. We see that the proper snap ring is 59 thousandths thick. The service manual tells us it's the snap ring with the blue identification symbol. Install the new snap ring with a pair of snap ring pliers. And before replacing the cover, be sure that the wave spring is installed properly on the synchronizer. There are 2 lugs that hold the spring in place. When installing the rear cover, be sure not to distort the oil guides. Apply sealant to the rear cover. The specified sealant is MOPAR silicone rubber adhesive sealant or equivalent. Now, install the rear cover. Before replacing the rear cover bolts, apply adhesive to the threads. MOPAR stud and bearing mount is recommended. Now, install the bolts and tighten to the specification provided in the service manual. That's the procedure for replacing the viscous coupling in the transaxle. Now let's remove the viscous coupling from the rear differential. After the rear axle gear carrier has been removed from the vehicle, remove the 8 bolts from the differential cover and remove the cover. Remove the 4 bolts that hold the bearing caps to the gear carrier. Mark the caps and remove them. Slowly pry out the differential carrier assembly with 2 hammer handles, being careful not to drop the outer race of the side bearings. And be sure to keep the right and left bearing components and spacers separate. Next, put the carrier assembly into a vise and make mating marks on the ring gear and both halves of the carrier assembly. Remove the bolts from the ring gear in a diagonal sequence. Now remove the ring gear from the assembly with a brass hammer or brass drift. Remove the 2 screws from the differential case halves, turn the case over, and separate the case halves. You can now remove the viscous coupling. Install the new viscous coupling in the differential carrier and complete the reassembly using the instructions in the service manual. The Lobro joint, or number 3 universal joint, on the 3-piece 4-joint propeller shaft assembly absorbs longitudinal movement and angle change and reduces vibration. As with any booted joint, the Lobro joint boot should be inspected once a year, or every 15,000 miles, for damage or leakage of lubricant. The Lobro joint consists of an inner and outer race, 6 balls, and a cage to hold the balls. When longitudinal or angular change takes place along the prop shaft, the balls move the inner and outer race grooves to absorb the movement. If the Lobro joint boot is damaged or leaking, the boot must be replaced. If the boot is damaged, the Lobro joint may also require lubrication or replacement. Okay, let's go over the procedure for servicing the Lobro joint. In order to service the Lobro joint assembly, you must remove the prop shaft assembly from the vehicle. First, support the prop shaft assembly and place mating marks at the rear prop shaft and differential coupling. You can now disconnect the coupling by removing the 4 bolts. Mark the prop shafts for reassembly. Then remove the nuts from the center bearing assembly between the rear and center prop shaft, and the center bearing assembly between the center and front prop shaft. Remove the rubber grommet from the muffler clamp at the center of the vehicle to provide clearance for prop shaft assembly removal. The shaft assembly is now ready to be removed. Slide the assembly rearward to remove the sleeve yoke from inside the transfer assembly, and then slide the assembly forward through the muffler clamp. You may need help removing the prop shaft assembly. With the prop shaft assembly on the bench, place mating marks on the companion flange and the Lobro joint assembly. Remove the joint retaining bolts and separate the joint from the companion flange. Then remove the rubber packing. To remove the joint from the prop shaft, remove the snap ring and remove the boot from the joint. Remove the joint from the prop shaft with a puller. Now, carefully loosen the boot band and remove the boot. To disassemble the Lobro joint, scribe mating marks on the outer race, cage, and inner race, and mark the outer race so that the balls can be reinstalled in their original positions. Remove the outer race and balls, noting location for reassembly. Clean off the old grease from the outer and inner race, cage, and balls. Check the ball grooves in the inner and outer races for wear, damage, or rust. Check the ball surfaces for rust, wear, or other damage. And check the cage for damage. If there is damage, replace the entire Lobro joint. If the Lobro joint is okay, reassemble it as follows. Apply a thin coat of the grease that's supplied in the repair kit to the ball grooves on the inner and outer races. Be sure not to use any other grease than that supplied in the repair kit. Put the cage on the inner race with the mating marks aligned and install 2 balls in grooves directly opposite each other. Both balls should be placed in their original grooves. Align the mating marks and assemble the inner race and cage in the outer race. When properly assembled, the recessed end of the inner race, the recessed end of the outer race, and the chamfered end of the cage are all on the same side. Rotate the inner race so that the remaining balls can be installed. Then, check that the outer race rotates on the inner race smoothly. Before installing the Lobro joint, install the washer and boot band on the center prop shaft and wrap the splined end of the prop shaft with tape. Install the boot on the prop shaft and then remove the tape. Apply all of the grease from the repair kit to the Lobro joint and apply a thin and even coat of the grease to the rubber packing and then fit the packing on the boot side end of the joint. Install the Lobro joint on the center propeller shaft while aligning the bolt holes and make sure it's properly seated. Secure the inner race with the snap ring and realign the bolt holes. Fit the boot on the joint and secure the boot with the boot band. Be sure to position the boot band clip on the side opposite the bosses, which are provided in the boot for ventilation, and then remove grease from around the bosses. Grease obstructs the vent air passage. Finally, check that the joint assembly moves smoothly. Apply a thin and even coat of grease to the other rubber packing and fit it onto the companion flange. Then, if using the old joint, align the companion flange with the mating marks. Reassemble and torque the bolts to the proper specification. Okay, the prop shaft can now be reinstalled in the vehicle. When towing an all-wheel drive vehicle, precautions must be taken so that the viscous couplings aren't damaged. The all-wheel drive Talon should be towed with all 4 wheels raised. Now, this can be done using a flatbed truck or with all 4 wheels on dollies. The shift lever should be set to first gear and the parking brake applied. The vehicle may also be towed with a rope or cable, as long as the front and rear wheels rotate normally and the various mechanisms function normally. To tow with a cable, the shift lever must be in the neutral position and the ignition key set to accessory. The point is, the all-wheel drive Talon must not be towed with one set of wheels turning while the other set remains stationary. Towing in this way will damage the viscous couplings. And one more thing, never try to start the vehicle by towing or pushing. Pushing or towing to start a vehicle with a manual transaxle can cause overheating of the transaxle and damage to the catalytic converter. In order for the all-wheel drive system to operate properly, it must be properly maintained. One of the most important maintenance steps is proper lubrication. As outlined in the maintenance schedule, the transaxle and transfer assembly lubricant should be checked periodically. The transaxle and transfer assembly have separate filler plugs, and they must be checked separately. To check the oil, be sure the vehicle is level. Then remove the filler plug. The oil level in the transaxle should be up to the lower edge of the filler plug hole. The oil level in the transfer assembly should also be up to the lower edge of the filler plug hole. When inspecting the manual transaxle and transfer assembly for proper lubrication, also inspect each component for evidence of leakage. If it's necessary to change the transaxle lubricant, refill with 2.3 liters or 2.4 quarts of the recommended gear lubricant. The transfer assembly requires 0.6 liters or 0.63 quarts of the recommended gear lubricant. The manual transaxle and transfer assembly require MOPAR hypoid gear lubricant or lubricant with an API classification of GLC 4 or higher and an SAE winter rating of 75W to 85W. A lubrication check should also include the rear axle. To check for proper rear axle lubrication, remove the filler plug and inspect the level at the filler hole. If it's slightly below the filler hole, that's okay. The rear axle with the limited slip differential should be checked at every engine oil change. The lubricant should be changed every 48,000 miles. The rear axle differential requires 0.7 liters, or 3/4 of a quart, of the recommended gear lubricant. Rear axle lubricant should have an API classification of GLC 5 or equivalent. MOPAR 75W90 gear lubricant is recommended for most temperature ranges. A rear axle lubricant viscosity chart for different temperature ranges is included in both the service and owner's manual. Well, we've explained how the all-wheel drive system operates. We've tested and serviced the Viscous couplings and serviced the Lobro joint on the prop shaft assembly. Finally, we provided you with towing and lubrication information. Knowledge of these service procedures should improve your ability to service the all-wheel drive system on the Eagle Talon.